Okay, in part C, it asks find the 0.05 critical value for the chi-square distribution with the appropriate number of degrees of freedom. Now, let's here. Okay, we have defined the hypothesis, we have calculated the test statistic. Now, we need to evaluate whether this test statistic shows supports the claim in the null hypothesis. How do we make this decision? We define a threshold value of chi-square statistic. So here it's called critical value. And the values that are larger this threshold critical value are accepted to be large. That shows significant deviation of observed values from the expected values. So if the observed calculated chi-square test statistic is greater than the critical value, then we conclude that the data do not support the claim in the null hypothesis. For the values below the critical value, then we say that it is okay, it's fair to claim that the data support the null hypothesis. And how do you find this critical value? Now, the probability of obtaining a critical value, a test statistic larger than the critical value, is called alpha. And most common value of alpha is 0.05. So the area to the right of critical value is 0.05. Now the total area under a probability distribution curve is 1. So the area to the left of critical value in this case is 0.95. So what's the critical test statistic value? Let's go to StatGranch and find the critical value. Now we need to open the StatGranch. Okay, you can go to Brightspace and open StatGranch, or there is a trick. You can go to question tree. Okay, there is a data table here. You open it and you click this box and you say that open the data in StatGranch. So it directs you to the StatGranch. Now we are in StatGranch. We go to StatGranch and open a new data table. Okay, here we go to stat calculators and we have chi-square. Now we need to enter a value for this shaded area to find the critical value. Remember, for 0.05 significance level, the area to the left of the critical value is 0.95. So we are looking for a value below which the probability is 0.95, right? And it is for a chi-square distribution with degrees of freedom 3. What is this threshold value? Let's compute it. So here, as the figure shows, it is about 7.85 is the critical chi-square value corresponding to a 0.05 significance level. So let's go back to question 1 and enter 7 point round to 2 decimal places. Okay, great. Now Using the critical value, what do you conclude about the null hypothesis? Now, the critical value is 7.81 and observed critical value is given as 2.8. Okay. So if the observed chi-square value is less than the critical chi-square value, okay, let's assume critical chi-square value is here. So, and the observed chi-square value is here. So the deviation of the observed values from the expected value is not significant. So we can assume the statement in the null hypothesis that we say that data support alternative, the data support the null hypothesis. In this case, it means that data do not support the claim in the alternative hypothesis. On the other hand, if the critical value, if the observed value is greater than the critical value, it is somewhere here, then it indicates a significant deviation of observed values from the expected values. So we say that data do not support the null hypothesis. In this case, data support the alternative hypothesis, right? So let's go back to question and see, using the critical value, since the test statistic is less than the critical value, we fail to reject. We support the null hypothesis. Since we support the null hypothesis, we say that there is not sufficient evidence in favor of the alternative hypothesis, the main claim. So there is insufficient evidence that births are not distributed uniformly across the seasons. This is the main thesis. Okay, let's check. Okay, great. Okay, here let's look at this question. Here, the distribution of ethnicities in the police departments. The question 2 talks about distribution of ethnicities in the police department versus the distribution of ethnicities of the city's youth. In particular, it talks about that census data for a city indicate that 28.3% of the under 18 population is white. This percent is Black, Latino, Asian, and other ethnicities. Okay. What is this? Census data for a city under the age of 18. Okay, youth population in the city. On the other hand, the city points out that 25,185 police officers, this percent is white, Black, Latino, Asian, and remaining are other ethnicities. So the observed values are this. Out of these police officers, these much white, Black, Latino, etc. observed. Do the police officers reflect the ethnic composition of the city's youth? Now, in this case, what do we test? We test if the frequency distribution of the police officers in the city follows the frequency distribution of the youth population in the city. Okay, so the expected distribution is the one of the youth population. Okay, so while trying to understand the question, so we are checking, we make a claim of indifference. So we say that the distribution of ethnicities in the police department represents the distribution of ethnicities of the city's youth, versus does not represent the distribution of ethnicities of city's youth. Okay. Next, we need to prepare a data table. Okay. So here the expected values are the ones of the youth population. So here we have, first of all, we have a categorical variable showing ethnicities, 1, 2, 3, 4, 5 categories. And for the expected values, we have youth, and we for the observed one, we have the police officers. Now, one thing we should be careful, here 1.9 for Asian is given, so the quantity in the other is not given. So we need to calculate it. Okay, so we add these 4 values, we get 99.8, then we subtract it from 100 and we get 0.2. So here we have these values. Now these are expected values. We should enter them in MyLab. Okay. Let's open a new data table. So the first column includes expected values. So it's 28.3, 28.7, 31.9, 9.8, and 1.3. Okay, and the second category is here. And it includes the observed values. So let's enter them. Okay, now then we go to stat, goodness of fit, chi-square test, and we click observed values. The name of the column that includes observed values is observed. You should enter the expected count. So here it includes under the expected. Now, if as in the first question, if you had tested if the distribution is uniform, then instead of entering the expected column, it would be okay if you select all cells in equal proportion. And then you click OK, compute, you get this. So here we have the chi-square statistic and p-value. So it is less than 0.001, so you can accept it as 0. It's a very small value. So the second method to decide whether the data support the null hypothesis or not is p-value approach. Okay, if the p-value is small, less than alpha, we reject null hypothesis, make a conclusion in favor of H1, and if p-value is larger than alpha, we fail to reject H null and make a conclusion against H1. Okay. So the threshold value here is the threshold value that we compare p-value is the alpha significance level.